Right, so real quick, I wanted to talk about position, velocity, and acceleration and how they relate to each other. So here in this example, we've got this ball up here and it has an initial velocity of v naught, um, and then it will go down this ramp and then come to a flat surface again. And and we want to look at the acceleration, velocity, and position graphs of of each of these. And I actually think instead of starting with the position graph, let's let's start by looking at the velocity graph because I think for most of us, velocity is the most intuitive. It's something like we've kind of seen, and then position and acceleration is um, kind of a little tricky. Um, So here with we start with an initial velocity. That means our velocity is constant and non-changing. Let's assume in this example that there's no friction on this ball, and so it won't slow down at all. Um, it'll start with this initial velocity. As it goes down, it'll speed up, and then it'll stay at that velocity down here. And so here we've got our initial velocity up till 2 feet, and then as it goes down, it's acted on by gravity. Gravity is 9.8 meters per second squared, and so that'll cause a linear change in in our velocity. Um, and then when it gets to the bottom again, it'll just stay at this velocity because nothing is acting upon it to increase the velocity. So I think by looking at this, most of us can figure out that the velocity will increase as it goes down the ramp. And so now, if we look at this in terms of the position graph, we're let's say we're starting at 0 feet, like up here. Um, we'll start at point 0, 0, and then we go to 2 feet. Our position will increase linearly. As we go down this ramp here, we have a linear change in our velocity, which will cause a quadratic change in, here, let's see if I can draw that better, a quadratic change in in our position, and then at the end we'll stay at the same slope, like so. And finally, for our acceleration, we have an initial acceleration of 0 because our velocity is not changing. So for the first 2 feet, we're just down here. Then things get interesting when we hit that 2 foot mark and we start to accelerate. Our acceleration, 9.8 meters per second squared, and that'll actually be a jump change here. And then once we hit 4 feet, we'll come back down and our acceleration is now is now 0 again. So I hope this helps and kind of like explains a little bit of like position, velocity, and acceleration, and you guys can now figure out all of the problems in your physics homework.